AI, machine learning, deep learning. I mean, you hear these buzzwords everywhere, right? From the news to the features on your new smartphone. But what's the real difference? Are they all the same thing? In this explainer, we're going to strip away all the jargon and build a simple, really clear picture of how they all connect.
So, where do we even begin? Well, before we can even touch artificial intelligence, we kind of have to take a step back and ask a much bigger question. What does it mean for any of us to be intelligent in the first place?
All right, so for our first section, let's just set the stage. Before we can talk about machines, let's take a look in the mirror and break down the fundamental building blocks of our own intelligence. It's so easy to think that intelligence is just about being smart or knowing a lot of facts. But look at this definition. It's so much more active than that. It's a process, right? It's about learning and adapting and actually using what you know to get something done. And this whole process really boils down to three key parts. First up, there's learning, just taking in information from the world around us. Then we use reasoning to make sense of it, to connect all the dots. And finally, we put it all into action with problem solving. This is basically the blueprint for intelligence, whether it's ours or, as we're about to see, an artificial one.
Okay, so we've got our blueprint for human intelligence. How in the world does that translate to machines? Well, this is where we step into the fascinating and, yeah, often confusing world of AI.
Okay, this is it. This is where we tackle the big three buzzwords: artificial intelligence, machine learning, and deep learning. Let's really peel back the layers here and see how they actually fit together. So let's start at the very top with artificial intelligence, or AI. Here's the most important thing to remember. AI is the giant umbrella term. It's not one single thing. It's the entire field dedicated to making machines do things that we would consider smart. So how do you actually do AI? Well, one of the most popular ways today is through machine learning, or ML. The best way to think about it is this. Instead of a programmer sitting there and writing millions of if this, then that rules for every single possibility, you basically just throw a mountain of data at the computer and say, here, you figure out the patterns. It actually learns from experience.
And we can zoom in even one level deeper. Deep learning, or DL, is like a superpowered, souped-up version of machine learning. Its secret sauce is something called an artificial neural network. And look, don't let the fancy name fool you. It's really just a system that's built to process information in layers, kind of like how our own brains are wired.
This slide right here really pulls it all together. The absolute best way to picture this is like those Russian nesting dolls. AI is the big outer doll, the whole concept. You pop it open, and inside you find machine learning, which is one way to build AI. And then you open that one, and you find deep learning, a really powerful, brain-like type of machine learning. But here's a really interesting twist. Not all AI is about replacing humans. In fact, some of the coolest stuff happening out there is designed to be more like our partner, to actually enhance our own abilities. Let's dig into that a little bit. So here we've got two really different ways of thinking about it. On one side, you have augmented intelligence. This is AI as your co-pilot. Think of Grammarly, suggesting a better word. It's not writing the email for you, it's just making you a better writer. Then on the other side, you've got cognitive computing, which is a lot more ambitious. It tries to actually simulate the human thought process itself, to understand things like context and nuance, just like a person would. And that's the bottom line, really. It's this crucial distinction right here. While some AI might be aimed at completely taking over a human task, technologies like these are all about giving us a boost, enhancing what we can already do. So, this all leads us to a really fundamental question, maybe the question. We've seen how we're trying to make machines think like us, but what are the deep, fundamental differences that are still there between a human mind and a machine one? This table gets right to the heart of it. First, emotion. A machine can be trained to recognize the word sad or even spot a frowning face in a picture, but it can't actually feel sadness. And second, creativity. Now, an AI can create some amazing art or music, but it's always remixing and reinterpreting patterns from the data it was fed. It can't have a truly original, out-of-the-blue idea that isn't connected to its programming. So where does all this leave us in the real world? Well, it helps us draw a really clear line in the sand between the AI that's already here, in our cars, on our phones, and the AI that, for now, only exists in the movies. Let's break it down.
What's real right now is what we call limited memory AI. A self-driving car uses this to remember where another car was a few seconds ago so it doesn't crash. But then you get to the next levels. Theory of mind, an AI that truly gets what you're thinking and feeling, or full-on self-awareness, like Wall-E or Jarvis from Iron Man. Yeah, that's still firmly in the land of science fiction. At least, for now.
Which brings us to our final big thought. We can engineer machines that learn and reason and solve unbelievably complex problems. We can even build them to mimic how we think. But given that huge gap between just processing data and actually experiencing consciousness, will a machine ever truly feel anything at all?